So in addition from going to rectangular to polar form, we also want to be able to go from polar form to rectangular form. This is actually much quicker, and many of our final answers they will ask for us to put into rectangular form. So it's good to be able to know how to do this, to be able to do this very quickly. So notice that we have a number on the outside of some parentheses, and right away your Algebra 1 brain should be screaming at you, can't we just distribute? Yep. We also have two trig functions we could evaluate. We've got that cosine and that sine on the inside, so that's going to be a unit circle lookup. So if you're looking for a quick algorithm to go from polar to rectangular, hey, it's a unit circle lookup and a distributive property. It is very quick. So 3 pi over 4 is our angle. Again, jumping back to the unit circle to try to find that sucker. 3 pi over 4, hey, there it is. So our cosine is going to be negative root 2 over 2, and sine will be positive root 2 over 2. Wrong slide. So we still have an 8 hanging around for now. That 8's going to be distributed into both of those terms. Go ahead and let that 8 be green. So we have an 8. And then we also get the negative root 2 over 2 from cosine. Be careful because there's still an I hanging around here. We don't want to lose that I. So we have plus I times sine of 3 pi over 4, and that sine of 3 pi over 4 will be root 2 over 2. So again, just kind of showing off what the colors are here for. That 8 is for this whole number 8 that's outside. That's our absolute value of the modulus. That's been distributed to both of these terms. If this order right here bothers you, don't worry, we are about to change it after we simplify. So note when there's an 8 times something over 2, we can reduce that. 8 over 2 reduces to 4. Same thing here, 8 over 2 reduces to 4. So our real part will be the opposite of 4 root 2. And our imaginary part, usually we want to go whole number, then the I, and then the root 2. Looks a little bit cleaner that way. So that is going from polar form to rectangular. It's a unit circle lookup and a distributive property. There might be some things that cancel, there might be some simplifying to do, but it is much quicker to go this direction than the other direction. Let's do another one. Taking a look at 14, 2 pi over 3, that's going to be our unit circle lookup. 2 pi over 3 is right here. So cosine is negative 1/2, and sine will be root 3 over 2. So once again, we'll go ahead and let that modulus be green. So there is a distributive property happening here. Cosine of 2 pi over 3 was negative 1/2. Once again, we want to make sure we keep that I around. So there's still an I. We still have that 2 from the distributive property. And then we have a root 3 over 2. So there's a bit of cleanup we can do here. 2 times a 1/2. Well, those 2's are going to cancel. Hey, guess what? They also cancel here as well. So this one's a little bit nicer than the first one. All I have left in my left term is just a negative 1. And on the right, I only have the I and the root 3. Jumping down to 15, might as well go ahead and finish this one out. Again, we'll let that modulus be green, and it is going to be distributed into those two terms. But now I need to look up cosine of 11 pi over 6 and sine of 11 pi over 6. So jumping back to the unit circle, 11 pi over 6 is way down here. So cosine of 11 pi over 6, that'll be root 3 over 2. Sine of 11 pi over 6 is negative 1/2. So again, that was a root 3 over 2 and a negative 1/2. So there'll be a bit of cleanup that we can do here. Note we have 4 on top, 2 on the bottom. Those will reduce to give us a 2. 4 divided by 2 is 2. I also have a root 3 times root 3. Root 3 times root 3 is just 3. So that will give us a value of 6 for the left. And then on the right-hand side, 4 and the 2. Once again, 4 divided by 2 is just 2. We don't want to lose the negative sign there, so I'll go ahead and change that now. So we will have a negative. This time the radical is going to hang around. We don't have an extra root 3 to make that a whole number. So we still have a 2, we still have an I, and we have a root 3. And last but not least, might as well do all 4 of these. If you're getting sick of it, just skip it. You've already seen 3. But if you're still kind of like, no, one more example, please. We'll let that modulus be green for the last time. So we have a couple of 5s hanging out. And now what we're looking up in the table is 3 pi over 2. So 3 pi over 2, that's one of our quadrantals. That is this direction. This one's not too bad because cosine of 3 pi over 2 is nothing. Y is going to be -1. So we're going to have 5 times nothing. And then we'll also have 5 times the -1. So cleaning that all up, this whole thing becomes the purely imaginary number, -5i. Again, that negative coming from right here, -1. So it is possible to get an entirely imaginary number or an entirely real number. We don't see the real case as much, but it can happen, especially when we get into taking radicals. So there we have it, converting from polar to rectangular. I will see you next time for a bit of multiplication and division.